Hello, those of you who are watching this video might already pick a research area or thinking about switching your area or looking for a new research area to jump into, or you just have a lot of free time. I have worked with many students both in the United States as well as outside the States, and I find that picking a research area is not an easy task. The biggest problem that I see is that in most undergraduate or even master level classes, we don't really talk about research. And so students sometimes have bias or assumptions or some misunderstanding about what certain areas mean. They have assumption what research in machine learning implies or what innovations in operating system entails. In this video, I want to emphasize that what you learn in classes is far different from what's really taking place in the research world. I will take a look at two simple examples, again, machine learning and operating systems. The first one is many students say to me they like machine learning, they want to do AI, ML, or large language models. But when I ask them, well, tell me, what does research in machine learning mean? What kind of innovations are people making in the field? And they cannot really answer it. I don't blame them all. When I was an undergrad, I had zero clue what many different research areas mean. But last time, we already discussed the importance of knowing top conferences and journal acronyms. By knowing conference acronyms, you can go to these conferences' websites and learn more about what the research community is doing. For example, if we go to csranking.org, we go here, and we go to the AI area, we could see that there are 5 major sub-areas: artificial intelligence itself, computer vision, machine learning, natural language processing, and web and information retrieval. And if we pick the core AI itself, we can see conference acronyms like AAAI, IJCAI. Okay, now let's go to AAAI 2024 technical program. Let's go to its website, right? And you could see again all the main track, oral presentation, and so on, right? And you could see again all the conference name. Again, as like last time I told you, you could also go to dblp.org and type AAI, right, and take some time. But you could see again, total, there are maybe 22,000 papers in this conference in the history of this AAI conference, okay? And then you could look at whether you like the areas, you like the titles, and if you truly like AI or ML, right? So again, what we could do is also, you could Google AAI 2024 Best Paper Awards. And for example, here, we could find it. Let's pick one paper: reliable conflictive multi-view learning, right? You search for it, you go to this find this paper archive website, and if you click here, right, you could view the PDF, and again, you get the PDF, you could read and basically skim and review the paper. Okay, as you skim the paper, again, you scroll. Of course, the first 2 pages are enjoyable to read, but you need to read deeper, right? You might see algorithms, proofs, equations, formula, lemmas, etc. And you need to ask yourself, first, do you understand the paper? Second, do you enjoy reading the paper? Because you might understand it, but you might not enjoy the area. And 3, can you see yourself making similar innovations in 2-3 years down the road? Again, you might enjoy it, but you must also convince yourself that you're capable of making innovations in this area. Remember, there's a big difference between you liking the products of AI and ML versus making innovations in those areas. Okay, so that's machine learning. Another example of student bias or assumption that I often see is in the area of operating system, which is my field. If many of you have taken the operating system class, you will get the impression that operating system is about the inside of Linux, Windows, or Mac operating systems. And some students would even say, nah, I don't want to be a Linux developer. That's just too low level. I don't want to go into operating system research. Now, that's a wrong bias. Again, I don't blame the students, but that's just the reality, that there's a disconnect between classes we took and the real research world. Now, again, we already know the acronyms in systems and operating systems. We can go to csrankings.org again and go to pick the operating system conference. And you could see again OSDI, SOSP, Eurosys, Fast, Justic, ATC. Again, let's pick OSDI as an example. You could go to the google.com and type OSDI 2024 technical program as an example. You go to the OSDI 2024 technical sessions, and we're going to go to here. Okay, so let's just, again, like last time, let's go through the session names, right? You will see, memory management in the first session here, right? And boom, in the second session is about, low latency large LLM serving. It's about large language model, right? See, even the operating system conference also touches areas like LLM and ChatGPT stuff. Because again, behind ChatGPT and other LLM servings is big infrastructure. And that's where systems research lies, okay? All right, so let's continue. Again, we have distributed systems. And, look, the next day is machine learning again. It's deep learning, about tensor programs for deep learning, about hardware-aware tensor transformation, in-network ML models, right? Deep learning training, and so on, right? Okay, so again, you see it's another machine learning topic in the operating system conference. So again, we have operating systems, just low-level stuff, kernel stuff, right? But again, we also have high-level stuff, right? Doesn't have to be inside operating system, but we also have, cloud computing high-level stuff. Next, we have formal verification. We have cloud security and data management, like databases, analysis of correctness, and see, another machine learning conference, ML scheduling. What is it about? Is again, when you have a lot of machine learning jobs for training or inference, right? You need to schedule them because they're co-located on the same machines. You need to kind of basically schedule them. So hopefully it is very, very clear from these two examples with the simple illustration that, AI is not AI or OS is not OS, meaning again, what you learn in the class is different what you see in research. And again, like in the operating system conference, I would dare to say that more than 50% of these papers are not really about the low-level Linux kernel, but they're about building big systems in general, higher level, and are very well connected to other areas, including AI, machine learning, database, network programming language, security, and basically many others. Okay, so that's just two examples from the AI and system worlds, but you can apply the same stories here to your own field. Maybe some of you like drones, self-driving cars, bioinformatics, robotics, Internet of Things, right? Likewise, you must find the research communities. So do you like robotics? Check out the robotics here, the robotics community here, ICRA, IROS, RSS, and so on, right? You might like using robot, but you need to double check if you like the kind of innovations that the robotics community is making. You like self-driving cars. I bet the mobile computing community here, Mobicom, Mobisys, Sensis, has a lot of papers in that area. Read them, see what kind of papers they publish. Likewise, if you like Internet of Things, I bet it's kind of covered by this community as well, although it's also covered in the networking community and architecture community as well. Bioinformatics, sounds cool, right? Go to these conferences, right? So again, kind of, dig deeper into these conferences and these communities. So to recap, do not make assumptions. By not making wrong assumptions, you could immerse yourself to what the community is doing and make a fitting decision for yourself. Okay? All right, next time I'll describe more tips in this topic on how to choose research area. See you next time.